Hey, welcome to Statistical Methods Exam to Review. So this exam, oops, accidentally clicked on the wrong thing. So the exam that we are looking at, if you're in our math resources Canvas page and you want to follow along with this video, or you're trying to find this video later on, under Statistical Methods, click on that little card, dashboard display, whatever you want to call it. And then right over here, test review material. And we are doing version A for this video. So this is the blank document that you can download. We are working on the solution guide right now, and the video will be posted once we are done recording this video. So there's everything that we're working on right now. So let's jump into this. Let's get started. I have StatCrunched open. I also have the TI-84 ready to go. I will mainly use the StatCrunch and then mention how to do things on the TI-84. Because as students, you should have access to StatCrunch during your exam, unless your professor otherwise says so. All right, so everything's ready to go. Let's dive into this. So our first question, and again, this will go in order of the way that you learned it. It starts in chapter 4, and then we'll jump into chapter 6. So right now we're in chapter 4, and we're talking about scatter plots. So the accompanying scatter plot shows the data on age, denoted A, of a sample of students and the number of college credits, C, attained. Comment on the strength, the direction, the shape of the trend. So we've got multiple choice here. So looking at this, what do we think about what's going on? What are your thoughts? A, B, C, or D?
I think it's B.
And I would go with that because this trend is definitely strong. Positive trend right here, positive linear. And then all of a sudden, just after 24, it's like it becomes negative, but it's weak sauce. Okay, definitely B is what I would go with. Any questions on number 1? All right, number 2. So here, the scatter plot shows the number of brothers and sisters for a large number of students. Do you think the trend is somewhat positive or somewhat negative? What does the direction, positive or negative, of the trend mean? Does the direction make sense in this context? So part A is asking us, what is the trend? And what does it mean? So what do you think?
I think A.
You think A? So we say the trend is positive, and I would agree. The trend is definitely positive because my dots are going up as we move left to right. And then since my dots are going up, it means the more sisters a student has, the more brothers a student will have. So that's the trend. The more sisters tends to have more brothers. Part B. Does this make sense in the context of the problem? Make sure that you read the sentence completely. because there are small variations in these. What are we thinking?
I put B.
Ruben, do you agree?
Because large families are likely to have a large number of sons. Correct, I do.
Okay, yeah, and it is B. Again, that slightly difference down here is like likely to either have a large number of sons or a large number of daughters. And that's not what's going on here. It says the more sisters you have, the more brothers you're gonna have as well too. That's what this trend is saying. So it's very important that you have the and in there. It's not an either or, it's you get one, you also get the other. So B is definitely the choice. All right, number 3. So this one says the scatter plot shows the number of hours worked per week and the number of hours of sleep per night for some college students. So question A says, does the graph show an increasing trend, a decreasing trend, or no trend?
No trend.
No trend, right? But there
Correct.
isn't really a no trend up there, which kind of makes this question boo. So which one would be the closest answer to a no trend?
B, very little trend.
B, very little trend. Good. Very little trend. And then question B, explain. Why do you believe that? So which one of those explanations is what's going on? And anyone can answer, Brooke or Louisa.
I put C.
See, absolutely. Because that's the only answer that says that there's not a relationship. It doesn't seem like there's anything going on.
No trend.
A, B, and D all talk about some sort of trend. But there isn't one. You guys are doing great. Moving right along. There's only 20 questions and we're on number 4 already. The figure shows a scatter plot of birth rate, live births per 1,000 women, and the age of the mother in the United States. Would it make sense to find a correlation for this data set? Explain. According to this graph, at approximately what age does the highest fertility rate occur? And would it make sense to find a, seems like we got a little repeat of questions there. Let me double check and see if there's no follow-up. So this one, it really is only the first part. It's, would it make sense to find a correlation for this data set? Explain. There aren't the other 2 questions. So. What do you? Sorry, go on.
Is it C?
It is C. Because remember, we are all about linear, linear, linear. And that correlation, they're talking about that correlation coefficient. We don't find correlation coefficients unless we know it's linear in nature. Okay. So definitely C. Linear, linear, linear is what we want. All right, number 5. Let's talk about that correlation coefficient. Let's talk about R. So this is a little bit of matching. So we want to pick the graph that goes with the following correlation coefficient. So we can do these in any order we want. One graph should be really, really easy to locate for who it goes with. Well, I mean, they're all not that bad, but one graph only makes sense with one of these. Talk to me about what you're thinking.
For A, I put 2.
A is definitely 2. Because the closer you are to 1 or to -1, the more it looks like a line. And this one is really close to 1, and 2 is the one that looks the most like a line. And what were you saying about B, Mariah?
B, I put 1.
Absolutely. And this is the one I was talking about a moment ago. B is the odd man out. It's a negative correlation coefficient. So there's only one graph up here that has a negative trend. So if you have a negative correlation coefficient, you have a negative line. There's only one graph that looks like that, and that is 1, because my dots are going down from left to right. So this graph is the only one that can go with this guy, because it's negative. And then last but not least, by process of elimination, C is what?
3.
Absolutely. It's the one with the least amount of trend. It almost looks like just a regular old dartboard where we're throwing darts at the board, just trying to hit anything we want. Good. See, this exam's not so bad, right? All right, so we have an equation here. Daughter equals 20.66 plus 0.686 mother. We've got our scatter plot here, the heights of the mother and daughters. So we want to answer some questions here. So the first one says, as the data are graphed, which one is the independent and which one is the dependent? So the independent variable is who?
The daughter.
No,
The mother.
the mother. Independent is always like the x-axis. The mother's height is the independent. Then the dependent has to be
Why?
Daughter.
Daughter.
the daughter. The y, you got it. Because the daughter's height depends on the mother's height to a certain degree, of course. So again, when you're looking at your scatter plot, the independent is always your x-axis. The dependent is always the y-axis. All right, part B. It says from the graph, approximate the predicted height of a daughter of a mother who is 70 inches tall. And it says right here, round to the nearest inch. So the mother is 70. So kind of seeing this. So it goes to right about there. And then if I go across from there, what's that y value over here? So to kind of highlight it a little bit more for you. It's that y value there.
69.
I could go 69, maybe even 68, but definitely it's between those two. So in that blank, we would approximate 69. Any questions on that so far? Part C, this is where they want us to use the equation. So what are we gonna do with the 70?
We're gonna do 20.66 plus 0.686, and then in parentheses, put 70,
You got it.
just to substitute.
Correct. All they want you to do is to substitute in. This is where the mother was. So we plug the 70 in. And let's go ahead and get the full answer to this, and then we'll deal with the rounding.
It's 68.68.
68.68.
Yeah,
Perfect.
so it's already rounded.
So let's see where they want us to round to, just to make sure. So it says round to the nearest 2 decimal places. And just like Mariah said, we don't have to do anything because this is already 2 decimal places. So no rounding needed. Any questions on number 6? Just a straightforward plug and chug on that last part. Which kind of verifies the 69 that we said in part B.
Correct.
All right, from here. Let's jump back in. Oh, there's a D and an E part to this, so let's talk about those. Thought we were done. So D says, interpret the slope. Interpret the slope. So when we come back to this, which one of these numbers is the slope?
That's 0.686.
You got it. This is our slope. So kind of thinking in terms of the context of the problem, bringing us back to our graph here. What does this slope mean?
C,
See? So let's
Yeah,
try-
I agree.
for each inch in the mother's height, the average daughter's height increases by about 0.686 inches.
Perfect. Yes. Because the slope is all about a 1 unit change for the X for every, for the average, whatever is happening on the Y. So, and this says for each inch in mother's height, so 1 unit change, the average daughter's height increases about 0.686 inches. So the slope is always about 1 unit of change for the X, and that tells you the average Y change. Perfect. Nice job on remembering that. But we know that the daughter's height is affected by more than just the mom. So what factors below affect the daughter's height? And it is a select all.
The father's height and the daughter's nutrition during her formative years.
You got it. So C and D. C and D. The father's height and their daughter's nutrition during the formative years. Perfect. Cruising right along. All right, number 7. Number 7 has multiple parts because we're going to be looking at multiple displays here. So number 7, part A. Well, reading this first. Measurements were made for a sample of adult men, assuming the association between their hand length and their foot length is linear. Output for the predicted foot length from hand length is provided from several different statistical technologies. So part A, report the equation for predicted foot length from hand length. Use the variable names foot L and hand L in the equation rather than X and Y. Round to 3 decimal places as needed. So what do we think is the equation? And remember, we have a technology display right here. We have a technology display right here. And down here. And one more right there. So which display do you guys want to look at? The TI-84, which is the bottom one, the Excel, the StatCrunch, or this is Minitab? Who do you want to look at to get our equation?
StatCrunch.
All right, let's go StatCrunch. So what is our equation? So here's our StatCrunch. What is our equation?
So the predicted, it would be predicted foot.
You got it, predicted. And I like that you put that there. Because up here, you can see below the blank that it is predicted hand or predicted foot. And so this is going to be like a drop down menu for you. So you choose predicted foot equals what?
12.3011870.
Ooh, careful. What are we rounding to?
To the 3 decimal places.
3 decimal places. So it doesn't want all that. So what is our value then?
So it's 12.301
Perfect. So 12.301 plus or minus?
plus
Plus
0.773.
Okay. And then the last is
Predicted.
careful. It's not
I'm
predicted.
sorry. Not predicted. It would be the hand, the independent.
And L, you got it.
Yeah.
So again, this is a drop down for you and you'll choose hand L. So our equation, once filled in, looks like this. Predicted foot L equals 12.301 plus 0.773 hand L. There's our equation for part A. All right, part B. So now we're going to look at these technologies. So over here we have the Minitab output, and they want to know, how do you find the slope and the intercept from this display? Not what is it, how do you find it?
Put B.
B, the slope is the number being multiplied by hand L, and the intercept is the constant. Absolutely. The slope is the number that is right next to your independent. It is always next to the independent. And the intercept is the one that is always the constant, meaning the number with nothing by it. So the 12.3 is the constant. Constant means it has no variables. So if you're thinking about this, this is y equals b plus mx. That's how that's kind of written. Y equals b plus mx. All right, C. Here we have the StatCrunch. How do you find the slope and the intercept from this piece of information?
It would be the same, so it'd be D.
It would be D.
I mean, I
Perfect.
think
It is the fourth line down, because if you count from the top, simple linear regression results is line 1, dependent is line 2, independent is line 3. Line 4 has the equation, and you can see our number being multiplied by hand L. So that's the slope. And you can see the 12.301 is the number that's by itself with no variables. That's the constant. Good. Okay. We don't talk about the R value because that's called the correlation coefficient. That's not slope or intercepts. All right, over here we have Excel. How do we find the slope and the intercept from Excel?
it'd be A.
A. The slope is the X variable and the intercept is the intercept. Absolutely. The X variable over here is how they are telling you that this is the slope, because what they're saying is this is the number times the X. This is the number times the X. Okay. And then intercept, that's self-explanatory. And then part E, this is from the TI-84. How do we find the slope and the intercept on this one?
Let's see.
It is C. Because this is basically your slope intercept equation, but it's written backwards. Y equals the B plus MX. So this A value right here is the intercept value because it's the constant. And this B value is your slope because it's right next to the variable X. So this is B plus MX if we're thinking in terms of slope intercept. Perfect. All right, we are almost out of chapter 4, I promise. Just a couple more questions. All right, number 8. And we've got 2 parts to this one. So it says the equation for the linear regression line relating the salary and the year first employed is given in this picture. And our equation is right above it. Okay. So report the slope and explain its meaning. And then we're going to talk about reporting the intercept and explaining its meaning. So what does this slope, and they're giving it away right here, of $2,099 mean?
C, a salary
C?
of 2,099 would be the salary for a person who started in year 0.
It is not C. You're thinking intercept there.
I put A.
Whatever, sorry, say it again, Mariah.
I put A.
It is A.
The average salary.
So what you're looking up here, when you got subtraction, that means it is going down every year as we progress.
Gotcha.
So A right here says the average salary is
Less.
2,099 less for each year later. So that's representing the 1 unit of move for the X. But on the flip side of that, you can think about it that the person was hired, or the average salary is 2,099 more for each year earlier hired. So if you go the reverse direction, you're adding 2,099,
Average more.
but it is A. Yeah, the C one is more towards the intercept, but that is the wrong idea for the intercept.
Okay.
Because again, remember, these two values represent averages. And there is nothing in C that says average. All right, part B, what does the intercept of 4,255,424 mean? Or explain why it's not appropriate.
I put C.
C, and I agree with C. Because this is what would happen in year 0. So in year 0, if I was hired for a job, I would make $4,255,424. Yes, please. But that's not appropriate for us because in year 0, that kind of money really did not exist for jobs. Perfect. Good job, Mariah. All right, number 9. And number 9 ends chapter 4. So questions 1 through 9 are all chapter 4. Questions 10 through 20 are all chapter 6. Okay, so data were collected that included information on the weight of the trash in pounds on the street 1 week and the number of people who live in the house. So question number 1, part A, and this is kind of like putting everything together. Is the trend positive or negative, and what does it mean? So the trend is blank.
Positive.
Positive, because that's definitely a positive slope up there. And your R squared, well, nope. As I say, your correlation coefficient isn't given up there, so, but we'll find it and it will verify that positive is the correct choice as well, because our correlation coefficient will be positive. But what does that mean? As the number of people per household increases, the weight of trash, what?
Tends
More
to
people tends to increase, yes. The more people I have in my house, the more trash is made. Perfect. So there's part B. The trend is positive, and as the number of people per household increases, the weight of trash tends to increase. B, now calculate the correlation. So between the weight of trash and the number of people. Right here is a nice hint for you. Use R squared from the figure and take the square root of it. So use the R squared and take the square root of it. And tell me what you get. And it says round to 2 decimal places.
I got 0.91.
Yes, it is 0.91. If you ended up with 9.10, let me tell you what happened. This is a percentage. We don't put percentages in the calculator. What do we do to percentages first?
Turn them into decimals.
Turn them into decimals. And that's what you need to do. You need to convert that percentage into a decimal, and that's what you take the square root of. Which will give us this number, and rounded correctly, like what Louisa said, is 0.91. This is the number my calculator gave me. Make sense? Gotta turn that percentage into a decimal before you take the square root of it. All right, jumping back in now. All right, part C. Talk to me about the slope. So the slope is blank.
14.47.
Perfect. 14.47. For each additional person in the house, there are on average blank additional pounds of trash.
Isn't it the same?
It is the same. 14.47 again. So as I add one person to my household, on average, I'm increasing my trash by 14.47 pounds. All right, D is all about the intercept. So we got to select a choice and then we got to fill in the blank.
I put D.
D. So let's explore D. And D is correct. It is inappropriate.
And then I put with 0.
Correct. In the blank goes the value 0. It is inappropriate to interpret the intercept because it does not make any sense to think of a household with 0 people generating trash. That does not make sense. If no one lives in a house, or in a house, it generates half a pound of trash. No, that's just silliness. Thank you for bearing with me as I write that sentence down. Okay. And that right there ends chapter 4. Are there any questions over the chapter 4, questions 1 through 9? Okay, let's get into chapter 6 and let's start talking PDFs, probability distribution functions. All right, so first things first, we got a question about determining whether these are continuous or discrete in nature.
Can you go over just really quick, the difference between those? Because when I was doing the homework for this part, I went through it about 4 times.
Discrete means that you can list and count them. There's like a beginning and an end. Continuous means that it's like a range of values. There are like infinite amount of answers. So when we look at this, the number of mint condition baseball cards in a collection.
So would that be discrete then?
That is discrete. That is discrete because I can show you each one of those physical cards.
Is it because it's the answer, the question is contained to a particular collection?
Correct.
Got it.
Correct. It is all because of a collection. A collection is never infinite in nature. Your collection has a finite amount of pieces in it. Okay,
Got it.
now it might be an extensive collection, a large one, but we could still count the number of mint baseball cards. All right, next one. The decibel level of a siren. Decibel means how loud it is, if you didn't know that.
Is that continuous?
That is continuous. Because that level has a varying range. You know, if a siren is pretty far away, it's going to be faint and have not a lot of sound. But as that siren gets closer to you, it gets louder and louder and louder. There's a continuous range of sound going on there. So that is continuous.
Would it be discrete if it was more like, I don't know the word I'm looking for, more explained, like more, like if it said the decibel level at this feet away, this many feet away,
Uh,
or no?
Probably not, because you'll still have a range of values that it could be at those particular instances.
Okay.
All right, so is the number of characters typed per minute discrete or continuous?
I say discrete.
Definitely is discrete. Another way, like usually when I think about the difference between discrete and continuous, continuous contains decimals. If your answer can be a decimal answer, it's probably continuous. Discrete are like hard, fast numbers. Hey, you typed 27 characters. Hey, you typed 25 characters. There's no doubt about it that those numbers existed in the number of characters. But if it involves decimals, then you're probably looking at continuous. Is blood sugar level discrete or continuous?
Continuous.
Definitely continuous, because there's a varying range of values there. Oops. I wrote the wrong letter down. Good question on that, Mariah. It's always good to explain things.
Yeah, I went through it. I went through it a few times, so.
No worries. Does that make a little bit more sense?
The decimal part, yeah.
And that's generally what helps me, like when I think about between them, like if there's a decimal, it's probably going to be continuous.
Okay. Yeah, there was some that were like, they weren't really straightforward necessarily on the homework. It's like, yeah, it could be both, I guess, depending on how you think about it.
Yep.
So I kept
All
getting
right.
one wrong and then I had to go back and do it again.
So our next one, we're going to fill in the table with the probabilities. Okay. So a magician has shaved off one edge of a six-sided die, and as a result, the die is no longer fair. The figure shows the graph of the probability density function, the PDF. So we want to convert this into a table. So I'm making my table real quick. So what is the probability of rolling a 1?
0.06.
0.06. Because my graph, if you haven't noticed, is counting by 0.02 as it moves up. So this is right at 0.06. All right. What is the probability for 2?
0.22.
0.22. And then what about 3, 4, and 5?
The same.
0.22, right?
Mhm.
0.22. 0.22. Okay. What
Six is the
about
same as one.
say it again?
6 is the same as 1.
6 is the same as number 1, which is 0.06. So this is what your table should look like. 0.06, then 0.22 for 2, 3, 4, and 5, and then 0.06. Easy peasy.
Equals 1.
You bet. And they should all add up to 1. As it says, well, it didn't say there, but it does say it later on. It's not on number 12 right there. So number 12, Eric wants to go skiing tomorrow, but only if there are 6 or more inches of new snow. According to the weather report, any amount of new snow between 4 inches and 9 inches is equally likely. The probability density curve for tomorrow's new snow depth is shown. Find the probability that the new snow depth will be 6 inches or more tomorrow. Shade the appropriate area and calculate the probability. So I've got 4 graphs here. Which one of these graphs shows, so there are 2 parts of this, shows the area we're looking for, which is 6 or more inches?
D.
D, absolutely. Give me a moment to kind of copy down my graph. This is where the exam takes at least the review is going to take a little bit longer because there's graphs now to be shown. And this is where, if you haven't noticed, I mean, it will slow down just a little bit, especially once we get into these later ones where you're looking at the a normal curve. So this is where you'll slow down just a little bit. Not all the way too much, but just a little bit. So this is the curve we are after. Because we want 6 or more inches. Okay. And that was D. Now part B says we want to find this probability. So the area under the curve, what is this shape?
Rectangle.
It's a rectangle. How do you find the area of a rectangle?
Length times width.
Length times width. So what is the length down here?
6, 7, 8.
3.
It is 3. 6 to 7, 7 to 8, 8 to 9. That is a length of 3. Okay. Length of 3. What is the width?
0.2.
0.2. So that is what you're going to multiply. 3 times 0.2. And what do you get?
0.6.
0.6. And I'm going to put 6, 0 because it is probability. And I'm pretty sure it's going to say 2 decimal places. Nope, it doesn't. But let me look at my answer key real quick just to double check that. They just had the 0.6. So you don't have to put the extra 0 on there. So 0.6 is just fine. And there you go. It's a 60% chance that he's going skiing tomorrow.
So for that, are we putting it, I know you said the answer, but would, with it being probability, would you put it as a percentage?
Nope, it doesn't say.
Okay.
If it wants a percentage, what you will see then is you'll see the percent sign after it.
Okay,
Okay?
Yep.
Only put the percentage if it's talking about the percentage or you see that percent sign.
okay,
Other than that, decimals, decimals, decimals are the way to go.
okay.
All right. So a little bit of empirical rule on number 13 and number 14. Both of these are going to be about that empirical rule. So let me get my picture drawn real quick, and then we'll start answering questions. -3, -2, -1, 0, 1, 2, 3.
Yeah, baby.
Close enough. All right, so we know that between says 68% between two. That is 95%. And that is almost all. All right, so here's what we got. So part A wants to know. Let me scroll up here so I can look at it real quick. There we go. What is the percentage between -2 and 2? What is that percentage?
B,
B?
yeah, 95.
Perfect. All right. The next question says, what is the percentage between 3?
Almost all.
Almost all, which is which number or letter?
I'm sorry, A.
A, which is almost all. Okay. Doing great. All right. C. What is the percentage
We got C.
between -1 and 1?
I got C.
C?
Yep.
So is that 68%?
Yep.
Perfect. So there we go. Fix this. Okay. D. So what is the percentage of z-scores more than 0?
D was 50%.
Absolutely. because you're talking about what's happening right here and you're going more than 0. So you're talking about all the shaded region over here, which is half the graph. Nice. And E. What is the percentage between 1 and 2?
C.
C?
Yep. It's 13.5.
Perfect. Because you take the 95 minus the 68, and that will give you 27. And that 27% makes up both of these regions. Cut that number in half and you get the 13.5. Good job. All right. So it goes B, A, C, D, C. All right, let's jump to number 14. So this one's going to kind of have data with it. And we're going to make our picture. So that's what part A is all about. Let's pick the correct picture. Give me a moment to write. All right, they're telling us that the mean is 50 and the standard deviation is 100. And we're looking at
Sorry, the mean
quantitative
500.
500. Sorry, I wrote 500, but I said 50. Thank you. So they're telling us this is the quantitative SAT scores that are approximately normal. That's why we got the normal curve here. Again, mean 500, standard deviation 100. The horizontal axis is all about the SAT scores. And provide basically the Z scores for those. And then we're going to answer questions using the empirical rule. All right, so let's jump to our graph. So who goes in the middle?
50%.
What?
500.
50%. 500. The mean goes in the middle.
Oh, 500, yes.
Yeah, and I always like to write my numbers up above. They like to put them down below. It doesn't matter. So when I go over to one standard deviation, in the positive direction, what number are we at next?
600.
600, because all you have to do is take the mean and add the standard deviation. So 500 plus 100 is 600. Where am I at when I jump over to 2 standard deviations?
700.
700, because you just add the standard deviation again to get from 1 to the next. 600 plus 100 is 700. Where am I at with 3?
800.
All right, where am I at -1?
400.
400, because now we're going backwards. So you're going to subtract the standard deviation. So 500 minus 100 is 400. Where am I at 2? -2. I should be more specific.
300.
Perfect. And at -3.
200.
There we go. So we just need a graph that matches those numbers. And when we jump back and look at that, that graph is which one?
B.
B. And there we go. And now all we're gonna do is we're gonna answer questions. But instead of like in number 13, how these were all Z-scores they gave you, these are all data values that they're giving us. Okay. All right. So let me get ready for this. And we're gonna do the same thing again. So B says, what is the percentage more than 500?
50%, so D.
50%, because you're right here in the middle and we're doing more than. That's just like the question we just had a moment ago of more than 0. So D, 50%. Question C says, what is the percent between 400 and 600?
I got D again.
Which is what?
68.
You got it. Because you're between one standard deviation. -1 and 1. That's the same thing that we had up on number 13. So it is 68% between those two. All right. D says it's the percentage more than 800. Excuse me.
Bless you, Professor.
Thanks. More than 800.
I got B.
Which is what?
0%.
Yeah,
Yeah.
practically 0%. I mean, it's like 0.15, if I remember correctly, percent. Really, really small. All right. E. So part E, what is the percentage less than 200?
B, 0%.
All right. B again, 0%, because you're way down here below 3 standard deviations. And I believe we got one more, right? Nope, 2 more.
2 more.
F wants to know what is the percentage between 300 and 700. Percentage between 300 and 700. So from -2 to a +2,
95%.
which is
C.
C, 95%, because that's 2 standard deviations. And the last one says, what's the percentage between 700 and 800? So this small little piece right here, what is that percentage?
2.5,
2.5,
which is B.
which is B. Okay. So there we go. And yeah. All right. Sounds good. Number 15. Now we're going to kind of get into the technology of this. So number 15, IQ scores had a population mean of 100 and a population standard deviation of 15 and are approximately normally distributed. Use one of the StatCrunch outputs below to find the probability that a randomly selected person will have an IQ of 120 or above. State which figure is the correct one and then answer the question. So which figure should we use to find the probability of 120 or above?
B.
B, no,
No?
nope. That would be 120 or below. When you shade to the left, you are all about being below.
That's right. Just above.
Above.
A.
So which figure should we be using?
Is A.
It's gonna be A.
120
So
or
part A
above.
is all about figure A, because that's the one where we have the shading that is above. So you can see 120 right here and it's all above. So we want figure A. All right. Part B, what is the probability that the selected person will have a IQ of 120 or above? Round to 4 decimal places.
1, 2, 3, 4.
Point, it's 0.0912.
Perfect. Because you're looking at it right here.
Yep.
Right there. And if you do 4 decimal places, Mariah gave it to us, it is the 0.0912. Perfect. All right, 5 more questions and then we're done. And then we made it. Yay. Okay. So we want to use technology to help us out. Okay, we can do that. And it says which graph below shows the area in a standard normal curve to the left of 0.68. Or in other words, below 0.68. Which picture is it going to be?
I have a question, Professor.
Mhm.
And because when they in some of these diagrams, sometimes I get confused. I don't know if they're is the shaded area or the non-shaded area.
The shaded area is what you care about always.
Gotcha. Okay.
B.
B.
B, absolutely. Because that is the one that has the number we're concerned with, and it is shaded to the left. Okay, we don't care about the negative 0.68. So any graph that has that on it is just junk. Now it says we can use our technology to help us out. So you really can do one of 2 things. And they are telling us we are using the standard normal curve. Okay. So if I'm doing the standard normal curve, what is the mean of a standard normal curve?
The mean it's 0.
What is the standard deviation?
1.
1. And they are telling us that we are below or to the left. So would I use a greater than or a less than sign?
Less than.
And then here is the number we're going to put in.
Correct.
So we just go to our technology, go out to StatCrunch, and I'm going to go in stat, calculators, scroll all the way down to normal. Look, it's already got the mean of 0, the standard deviation of 1. We've already got the less than symbol. All we got to do is put in 0.68. and hit compute. And there is our probability. And it says to round to 4 decimal places. 4 decimal places. What would that be?
2, 3.
Point 7.
517.
There you go. All right. You can also do this in the TI-84. I'm going to show the TI-84 for these next 2 problems. Well, actually, probably for the next 3. So if I go to the TI-84, I'm going to distribute. I'm going to do number 2. Since I'm going to the left, I'm going to keep that number there. I'm going to scroll down. I'm going to put in my upper value, which is 0.68. The mean is correct. The standard deviation is correct. All I got to do now is hit paste. So enter, enter. There's the same answer. Or you could do this by hand.
Yes.
By hand, we already know our z-score. It's 0.68. So here is the negative chart of the z-scores. Here's the positive. So we want to be down here. So I need to go to 0.6 and I need to go to the 0.08 column. And there it is. Notice this guy would have made me round up a little bit. So be careful. If it says use the technology, use the technology, because this would have us say that it's 0.7518 because of that 5 there. So if it says use technology, use technology. If it says use the chart, probably look towards the chart just to make sure that you're being accurate with what they want. Okay. But there is the percentage that, or the probability that we found. Lots of ways to do these problems. All right, let's jump to part B. Like I said, this is where there's going to be a little bit of a slowdown depending on what you're doing. So part B, again, we are using the standard normal. It wants to know which picture shows the curve to the right of 0.68. Which picture shows to the right of 0.68?
D.
Did you say D?
Yeah.
Yeah, correct. Because this one has the shading to the right, right there. So let me work this backwards. So if we were doing it by hand, we go back to that chart. Here was our number that we were working with. Here's that number. You would take this number and you would do 1 minus it. You would take 1 minus this to get the right-hand value. If we're doing it in the TI-84, second vars, go to number 2. And this time you would put 0.68 as the lower, and then 1 second E to the 99 as the upper, because this is the right hand. Keep this as 0, keep this as 1 because we're in standard normal. Enter. And there's the right hand probability. Which if we took 1 minus this, we would get the same thing. See, 1 minus, go up there, grab this number. Same answer. And then if we're in StatCrunch, this is how it would work. So in StatCrunch, we would change this sign right here from a less than to a greater than. And there it is. There's our picture. So rounded to 4 decimal places, what do we get?
.2483.
Okay. And there we are. Any questions on what I have shown you? All right. Moving on. So number, oops, wrong one. 17. Again, it's going to have multiple parts to it. Okay. So on this one, I will show the technologies again, but after number 17, I'm going to stick to StatCrunch. But I will show you everything. All right. So this one, it says, according to a statistical journal, the average length of a newborn baby is 19.3 inches with a standard deviation of 0.9 inches. The distribution of lengths is approximately normal. Use technology or a table to answer these questions. So here we should be fine with using either one. All right. So we're going to figure out what the curve is, and then we're going to find, and notice this one is a percentage because there's a percent sign after it. And we're going to round to 1 decimal place on these for all of them. Yes. For A, B, C, and D. All right. So we first want, what is the probability that a newborn baby will have a length of 18 inches or less? So which picture up here shows 18 inches or less?
C.
C, absolutely. That is our picture because there's the 18 marked and it's shading to the left because less is all about being below or to the left. So let's talk about our normal model notation real quick. So when we were dealing with standard normal, it was 0, 1, 0, 1. But this time we're not in standard normal. We're actually working with our data. So our normal distribution will be what, comma, what?
For this one, it would be 19.3, comma, 0.9.
There we go. For all of these, it will be because we're actually working with data. And so again, we're working with less, which means to the left. So we'll choose the less than or equal to, and then we know our number is 18. So let's go in and let's take a look from StatCrunch all the way through. So StatCrunch, we're going to come in here. We're going to change this up and we're going to say that this is 19.3. Our standard deviation is 0.9. We want the less than, and then we're going to put in 18 and compute. So rounded to 1 decimal place, what is the percent?
One percent.
No.
1 decimal point.
For
But
A,
remember that this is the decimal of the percentage. So you've got to move the decimal and then round.
for A, I got 7.4.
7.4 is correct.
That's right.
So you got to move that decimal 2 places to the left or sorry, to the right, 1, 2, that gives you 7.4307. And then round that to one decimal place is 7.4. Okay. Don't forget, you got to do a little bit of manipulating there with the decimal. Okay. Part B. Oh, sorry, by hand. If you do this by hand, and again, I don't know why you would want to do this by hand. We have technology that works really, really good for us. Or actually do it in the TI-84 calculator. So let's go to the TI-84 and then I'll show you by hand. So TI-84 calculator, go to distributions, go down to normal CDF. Our lower will be the -1 because we're going to the left. Second E99. Our upper will be 18. Our mu, or in other words, the mean, is the 19.3. Our standard deviation is the 0.9. And then hit paste and hit enter, and there's that number again. Okay. If you're doing this by hand, here's what's going to happen. If you're doing this by hand, the first thing you have to do is you have to convert this to a z-score. Because in order to use this chart, these are all about z-scores. So remember, to convert to a z-score, all you're going to do is take the 18, take your data value, subtract the mean, 19.3, and then divide by the standard deviation. And there is the z-score. So now we just go and look up this answer, -1.44. So we go to our chart. I'm going to need to go up to the negative versions. Here's -1.4. Get the top piece if I can. I need 0.44, so I go over to this column right here, and there's that same answer again. Be careful because this would tell you to round the 4 up to a 5. So just be careful. I would use the technology. Why would you want to take your time and do something by hand when we can have technology speed it up? But there it is. All right. Jumping back in. So there we go. Wrong one. Part B. Part B says, what is the probability that the newborn baby will be no longer than 20 inches? No longer than 20 inches. Oh, sorry. I put in a no. Will be longer than 20 inches. I am so sorry for misreading that. Seeing phantom words. So what is the probability that the baby will be longer than 20 inches? Which picture is it? Represents being longer than 20 inches.
Is it B?
It is B. Because being longer than 20 inches means that you can be above it. So that longer than is all about being above this. So that is a shading to the right. Again, everything stays the same. The only thing that has changed is the number we're looking at, and that we want to be longer than, which means for us, be to the right or above. So we want a greater than or equal to. And we know that our number now that we're going to use is 20. So working backwards, if we did this backwards, so starting with doing things by hand. 20 minus 19.3. And then divide that answer by 0.9. There's our z-score, 0.78. So we come out to our chart. I need to be on the positives, 0.7. I need the 8. So because I want to be to the right this time, I need to take 1 minus that answer. 1 minus this answer right there. Got it. Okay. If we do it in the calculator, second bars, normal CDF. This time we're going to make the lower 20. And the upper, because we're shading to the right, is the 1E99. Everything else stays the same. Enter, enter, and there it is. If we do it in StatCrunch, the mean, the standard deviation stay the same. Flip that to a greater than, make that guy 20. Enter. And there it is. So rounded to 1 decimal place. What is the percentage?
$21.8.
21.8. And last but not least, number C. Or number C, letter C. So this one says baby clothes are sold in a newborn size that fits infants who are between 18 and 20.6 inches long. What percentage of newborn babies will not fit into the newborn size, either because they are too long or too short? So which graph shows the between 18 and 20.6?
C.
Which one?
C.
No,
No.
D.
it is D.
Oh, the shaded.
D shows the between those two.
I think it's shaded.
Between means that you can be anywhere in that range. So D is the one that shows between. So again, everything still stays the same, except this time we're between. In the middle is another way to think about between. You want the middle. So when we go in there this time, we're going to put in 2 numbers, the 18 and the 20.6. So let's talk about how this works in all 3 different modes. So let's go to StatCrunch first. So StatCrunch, you're going to come up here and you need to click on between now. So this is the standard calculator when you're doing left and right shading. But when you're between, you're going to click on between. Notice things have changed a little bit. The mean and standard deviation are still the same. And then you just put your numbers here. Our lowest number is 18. Our highest number is 20.6. That's all you have to do. And then you're going to hit compute. Hey, look, that looks just like the graph we selected for D.
Man, incredible.
And there is the probability. So what is the probability to 1 decimal place?
$85.1.
85.1.
1%.
There you go. And Ruben, that answers the question that you had
Yes.
earlier for me.
Very simple.
Yes, very straightforward. If you're doing it in the TI-84, show you how that works. So in the TI-84, you hit second and vars, normal CDF. And then in here, you just put your two numbers, the 18 as the lower and the 20.6 as the upper. Everything else still stays the same. And there's the answer again. If you're doing this by hand, this is what's going to have to happen. You need to figure out both of the z-scores. So if you're doing this by hand, we need to get the z-score of 18, which again would just be 18 minus 20 point, sorry, 19.3 all over 0.9. And there's that z-score. Come up and grab that. And all I'm going to do is replace the 18 with 20.6. And there's that z-score. So basically, I need to go look up these two z-scores, and I'm going to subtract the two answers from each other. So if I come out here to my graph, 1.44 is right here. So I'm going to take 0.92507, and I'm going to subtract that from negative 1.44, which is right here. So I'm going to take those two percentages and subtract each other, and that will give me the same percentage we had a minute ago. Any questions on that? Okay. Hold on, let me make sure I read this one. Oh, so I misread in this one. And actually, Ruben, you were correct. We're not looking for the percentage that can fit in it. We're looking for the percentage that cannot fit in it. So Ruben was correct. It was actually C. I'm sorry, Ruben, for saying no. So the picture is C. Now, we know what this shaded region is, which is 85.1. How do I get this outside shaded region? What would I do with that number?
Would you do 100% minus the 85.1 and then divide it by 2?
Nope, don't divide it by 2
Oh, okay.
because we actually have both sides.
Yeah, never mind.
So what would that percentage really be then? What is 100 minus the 85?
14.9.
Here we go. Good thing I went back and looked at that just to make sure. Yeah, always make sure that we know what we're really after. So if we were after the percentage of those that fit in the close, that's what we'd be looking at with D. This is the percentage of those that fit in the close, but we're after those that will not fit in the close. So that's this outside. But the same idea still works. It's all about using this between feature to solve it. Ruben, you were right with that first graph.
And that's what I was having problems with.
Yeah.
Just the whole that in regards to, because the question was asking that same thing. It's not it wasn't the totality of it, was that don't fit into it. So
Yeah, so that would be the outside of that.
correct. Exactly.
All right, so from here on out, I'm only going to show the the stack crunch for this. So from here on out, I'm only going to show stack crunch. I'm not going to show the TI-84 manipulation or the do it by hand, because you've just seen that at least 5 times. And then you should have practiced it by now too. So you have your favorite method, whatever that might be. All right, number 18, just again, a little bit more practice. So what we have here is the distribution of white blood cells. White blood cell count per cubic millimeter of whole blood is approximately normal. Okay, so we have a mean of 7,525 and a standard deviation of 1,755. Use technology or table to answer parts A through C. All right, so part A, it says, what is the probability that a randomly selected person will have a white blood count cell between 6,000 and 10,000? So which picture is that?
Hey,
This is definitely the between one and not the outside one. All right, so all we got to do then is go to StatCrunch, put in the information, and we are between. So we're looking at the middle. And we have 2 numbers, 6,000 that we're going to put in and 10,000 that we're going to put in. So StatCrunch, we got to change the mean to 7,525. Change the standard deviation to 1,755. Our low value is 6,000. Our high value is 10,000. And let's make sure we know, what are we going to round to here? It is a percentage, and we're going to do 1 decimal place. Okay. So it is a percentage and 1 decimal place. So compute. There's that picture we talked about. So what do we do? What is the percentage going to be? Sorry, not what did we do?
72.8.
All right. 72.8. I like it. All right, jumping back in. Part B. An elevated white blood count can be a signal of an infection somewhere in the body. A white blood cell count can be considered elevated if it's over 10,500. What percentage of people have white blood cell counts in this elevated range? So which picture are we looking at?
BD.
D. We're definitely looking at being over. So above, or in other words, to the right. So it's definitely D. Which symbol are we going to use going to the right? Greater than or less than?
More than.
The more than, the greater than. And then our number we care about is 10,500. So we go to StatCrunch. We need to switch this out of the between. So we click on standard. There's our mean and standard deviation. We already have the greater than. We just got to put in our new number. 10,500. There's the picture we selected. And what is the percentage?
4.5.
4.5. Okay. Jumping back in. All right, so this time the white blood cell count below 4,500 is considered low. People in this range may be referred for additional medical testing. What is the probability that a randomly selected person has a white blood cell count below 4,500? So which picture represents that one?
See? Let me see.
I like it. Yep. It is C. And then now are we, so obviously we're looking at below.
It's less than.
So that's the less than or equal to because we shaded to the left. And the number we care about,
It's the 4,500.
4,500. So we go out to stat crunch. All that stays the same. Change this to a less than, change the 10,500 to a 4,500. What is the percent?
4.2%.
4.2%. Okay. Number 19, moving on. All right, number 19. This is a little different because we don't have any pictures this time. Okay. So here we might want to make our own picture so that way we know what we're looking at and things like that, but you don't necessarily have to. So it says the length of gestation for hippopotami is approximately normal with a mean of 271 days and a standard deviation of 8 days. That's a lot of days. All right. So if we're thinking in terms of normal notation, it's what comma what?
Wrong one. 271 and 8 day and 8.
There you go. 271 is the mean, 8 is the standard deviation. Okay, so part A, it wants the percentage of hippopotamus that have a gestation period less than 261 days. So what are we talking about here? Are we going to shade to the right or to the left? So what are we talking? Or in between?
The left.
To the left.
To the left. That's right, because we're less.
Then.
It's all about the left. So we want less than. And what number do we care about?
261.
So we can make a graph, but we don't have to. We've got all the information we need. We know this is the normal curve we're working with. We know that it's got to be less than. We know that this is the number. And so we do want percentages, and they're going to be rounded to 1 decimal place. All right, so let's jump out here. So we need to change the mean to 271. We need to change the standard deviation to 8. We like the less than, and we need this to be 261. There's our picture if we needed it. And what is the percentage?
10.6.
10.6. Perfect. Now, part B is different. And there's a little typo here. Not a big one, but a small one. We're not looking for a percentage. This should actually say days. We're not looking for a percentage here, but we are going to round to the nearest integer. So what part B is we are doing this backwards. We are dealing with the normal curve backwards. They are giving us the percentage. We want to know how many days is that. So let me show you the 3 ways we can do this backwards. Let's talk by hand first. They are giving us 8%. What is really 8%?
0.08.
0.08. All right. So if you're doing this by hand, when you work backwards, what you're going to do is you're going to go to, oh, I closed it out. Silly Mr. Armstrong. Let me go back and grab it. What you're gonna do is you're gonna come out to our table.
Mm.
And bring this back up. We're gonna look for the closest percentage to 0.08. And we're gonna find its z-score. So I need something that is close to 0.08. So here we're all in 0.03, 0.04. Oh, we're getting closer here. Here's like 0.076. That's going the wrong direction. I need 0.08. Ah, here we go. Right here. I want the one that is closest to 0.08. So looking between these, the one that is closest to 0.08 is this number that's right there. This one is 0.00073 away. This one is 0.00076 away. This one's closer. So what is this z-score? Well, it's negative 1.41. So we know that the z-score for 8% is negative 1.41. So all you're going to do is you're going to go in and we're going to solve the z-score formula backwards. So 8% is 0.08. And as a z-score, it is negative 1.41. All we're going to do is solve this backwards. Negative 1.41 equals our data point we're looking for minus the mean, which is 271, all over the standard deviation, which is 8. You're going to solve this problem. All you do is you cross multiply because this number is over 1. So if I cross multiply, I'm going to get negative 1.41 times 8, which is negative 11.28 equal to x minus 271. And then I'm going to add 271 to both sides. And that seems off. Hold on one second. Let's reread real quick because that is not the right answer. Make sure that we didn't misinterpret something. Only 8%, have longer. That's where we misinterpreted. If you have longer than, which direction is this percentage? Is that to the left or to the right?
To the right.
To the right. Remember that everybody in this, these represent percentages that are to the left. So we need to take 8% and subtract it from 100. What is that?
$92.
92. So we need to find 92%.
In percentage?
Yeah. or in other words, 0.92. So over here, again, we're stuck between these two. But again, the closest one is the 1.41. So I should have had the positive version of that. So that's an easy fix. So this is the closest to 92%, which represents the 8% to the right. And that's 1.41. So if I come back to my work wasn't that far off. Just a sign error. It's really a positive 1.41. And that's really a positive 11.28. So when I add to both sides, I find out that X is equal to 282.28. And if I round this to the nearest integer, how many days? How many days rounded to the nearest integer?
282.
282. So that's doing it by hand. You're just using the table backwards. Let me show you technology real quick. So in the TI-84 calculator, go to second vars. Right here, because we are doing everything backwards, that's called inverse. We are doing the inverse of the curve. So we are doing inverse norm. So you're going to go down to number 3. So we're going backwards. Tell it the area, and you can actually tell it the real area, but it must be the decimal. So 0.8. Our mean was 271. Our standard deviation was 8. And which one did we have? We were to the right. And then all we got to do is hit paste. And then enter one more time. And there's that number. There's our magic number again. If you're in StatCrunch, because StatCrunch is really, really easy. So in StatCrunch, oops, StatCrunch moved on me. There we go. In StatCrunch, all you're going to do, we like the mean, we like the standard deviation, because we want to be longer than, that means it's to the right. So we want to choose the greater than or equal to. This is the number we're looking for. So you got to delete it out. We're looking for this blank. But you do know the area or the percentage. So you put that in the blank. And as soon as you hit compute, our answer will pop up in the missing blank. And there it is. So when you're doing it, the inverse of this, you still put everything in. The blank inside with the inequality sign will be blank. And then you'll put in your percentage over here. Make sure you know which inequality sign to use, whether it's the greater than or the less than. There you go. All right, part C, we're back to normal. That's the only inverse problem on here. 19 C. So 19C, it says in 2017, a hippo was born at a particular zoo 6 weeks premature. This means her gestation period was about 229 days. What percentage of hippos have a gestational
than.
period of 229 days or less? All right, so everything still stays the same. Our mean is 271. Our standard deviation is 8. We are dealing with less. So which direction is that? Left, right, or center?
To the left.
To the left. So we want the less than symbol. What number do we care about?
229.
229. So we're just going to do 1 decimal place. So we're back to normal. So make sure that this is the less than symbol. Put in our new number, 229, and then hit compute. And what is the percentage?
0.0.
0.0. All right, last question, number 20. For all the marbles.
Okay.
So right here it says, assume that adults have IQ scores that are normally distributed with a mean of 100 and a standard deviation of 15. Find the probability that a randomly selected adult has an IQ less than 115. So in our normal notation, it's what, comma, what?
100,
Uh-huh.
comma 15.
All right. And so it says we want to be less than 115. So what direction are we going?
To the left.
To the left, because it's less. We're going to the left. We want the less than symbol. And the number we care about?
115.
115.
115. So we go out to StatCrunch, change up the mean, which is 100. Standard deviation, 15. Less than's already there. We need 115. And compute. Oh, we didn't look at what they wanted. So let's go back. They want the decimal rounded to 4 decimal places. So 0. What?
0.8413.
Perfect. And that is exam 2. Any questions, comments, or concerns? I'm so sorry for the mix up on those 2 problems with me misreading and misleading you for a couple seconds. At least we caught it now. We fixed it. Any questions about technology?
I have a question on technology.
All right. Does it
the-
pertain, does it pertain to the
Oh.
exam 2?
It does. It does.
So,
I just the thing is that every time I'm using StatCrunch, it's kicking me out of the when the StatCrunch icon is not on the problem and I choose to use it on my own.
mhm.
Every time I go back to insert the answer, it takes me out totally of the assignment. So is that what I'm afraid is if I was to do that during the exam and it kicks me out.
All right, hold on. Let
And
me
then we gotta go
stop
back
this
in.
recording.